Okay. So study we cover basics theory about these collections, Java collections, and now we are going to the move about this stream, where is stream and what the theory stream, and then we are going to talk couple of example so that you can okay, collect.
Yes.
So study the basic measures. Understand whenever you talk about the collections means there is a container that's hold different number of elements. Okay, element one, element two, element three, element three. That require the memory space to storing object. But let's talk about what the stream. Stream is not like a collection. First. Stream
Okay.
is not a collection. They are not required any kind of storing element. These are the not data structures. This is the data structure. They allow how you can store and after that you can get. But stream API is let's say it's just a pipeline you can say, or just like this is the one simple pipeline you can say pipe, and whatever the element in collections here, you are just read one collections and pass on this pipe, and they are pipe going to traverse, and they are again going to the out. And here out after that, again maybe you want to make another collections or list or set, then you can create another collections, and whatever the data elements you are coming from the collection, one collections, they are going to the process. Maybe different kind of functions, different kind of function you can apply here, transformation, conditional, and after that you are going to again store some again another collections. Okay? Collection.
Yes. So like here it means like we can create a collection from a collection.
Yes, you can say you can create a collection from collection. Might be
Yes.
maybe here output you want to collection, maybe not mandatory. Maybe just
Yes.
want to one specific value, or maybe two value, or arrays of value, right?
Okay.
Out, so outcome of the pipe is depend upon the our need. I want to collection, then we can collection. I want to just one string. I want to just maybe array. I want to just simple value. You can value. Like I want, this is the number of element. I want to just sum of the all number. The might be written only one value, right?
Mm-hmm.
So the stream is nothing, just provide a set of function or set of operations you can perform on each and every element of the collection. Okay, here collection maybe he, so stream is nothing, just a flow of your data, flow of element. You can pass any element, and here you can again get out the element. And during this time, during this pipeline time, set of operations, set of functions, set of behavior you can apply. Here you can say function 1, function 2, function 3, multiple function you can apply on this data, again this data, again this data, again this data, again this data, and it's go to the out. So stream is nothing, just you can say automatic reading input from one collections and perform some set of operation, set of function on those elements, and after that they again pulling out whatever the final outcome of your operation, the transformations, right?
So could you repeat the definition of streams?
Okay,
Group
a
of.
stream is just set pipeline of set of functions. A stream is a pipeline of a set of function.
Function. Set of
Function may
function.
be one, function may be two, function may be
Yes.
three.
Yes.
This means
Yes.
let's you create the four function. I can create two function, function one, function two, and function three. So I can create the pipeline of this function. And these functions are ready to take input and give the output. Take ready input, get output, right? So these functions now I can associate with a pipeline. We can make one pipeline here. And this pipeline just receive any kind of input automatically from the any source of data and perform each every function and then come out the data. So here
Okay.
they are not doing any kind of storage. They are not storing anything, just receiving and doing some set of operations and again
Set of
pulling out it,
operations. Okay.
right?
Yes. Yes.
So they never understand this is the data structure. This is not a data structure. This is just a set of function as a pipeline. Means you can say small function and these functions can be conditionally applied. Conditionally applied. This is not always needed. Sometimes conditional fixed then apply. Sometimes might be this two function apply. Sometimes three function apply. Depend upon the function behavior you want, right?
Yes. Yes.
So, so you can say sometime another definition is stream is a kind of a chain of function. You can say this is the function one,
Chain of
and
function. Yes.
again, yes, function two, again function three. Okay. So these function uh, can be in the sequential, can be in a parallelism, different order you can execute. And this pipeline or this sequence of chain of functions, this function have some specific nature. So let's talk what the specific nature of this function. Why these functions are not called as a method, right? Some in the Java sometimes so sometimes you call the particular method, sometimes you call the function, right? So whenever we talk about the Stream API, generally talking, we are saying this is the function or operation, right? So this different terminology you cannot saying this is the method one, method two, method three, right? So we'll
Yes.
talk
Yes.
why sometime before Stream API, generally Java have a concept class and method. We generally call all the method, right? But when Stream introduced, they say these are the look like a method, but I am saying this is the function, or you can say operation. So there are two kind of operations Stream API support. One operation, all these operations are functions, maybe intermediate operation or maybe terminate operation. Yeah, last operation, yeah, terminal operation, right?
Terminal.
So, so what do you mean by intermediate operations and terminal operation? Terminal operation is your last operation. Is your last pipeline function would be the terminal operation. Yes, from here, finally you are getting the output. Okay, but
Yes. Yes.
each function take input and returns out. Take input and return out. This is the only behavior. So
So here,
sometimes,
output
yes,
means like the output will
output
be in the form of
means
stream.
uh depend
Out
upon the depend.
like
We'll talk.
if I'm using the stream function and I am applying the filter or map, so at
So,
that moment I will get the return type is stream class.
so here I'm not just talking to what kind of input and what kind of output. Just assume whatever kind of you are receiving, maybe you can receive input integer, float, string, and output can be integer, string, different. Depend upon which function you are associating inside, right?
Okay.
These
Okay.
functions are some predefined functions which
Hmm.
already JDK given us, but this pipeline is open. You can define your own function as well, right? And you can give what would be the output or what should be the input, right?
Okay.
But generally, you are right. Generally, you are right. Always, our all the stream function look like they are take input as some data and return maybe a stream of some kind of data. Okay.
Yes, yes. In the generic,
Yeah,
if it
it's
is
a
returning
generic kind of
integer.
data. Maybe it's a stream of
Yes.
integer, a stream of float, a stream of something.
Stream
So
of
you are right.
generic integer.
So
Yes,
generally,
yes.
all the intermediate operations, this is the behavior, they take input and return the streams of the particular element. Okay,
Yes.
and but when you receive the terminal operation, last terminal operation, this will take receive input and might be the output of this terminal function would be not a string, actual number, maybe element of integer, float, double, collection, anything else. So terminal operation takes input but return not a stream, return actual value, maybe return void, maybe return function, maybe return a string, maybe anything, right?
Yes, yes.
But all
Optional.
the intermediate operations, always you can say, right, return the stream of some data. Okay,
Yes.
due to set, we can say this is the stream is a pipeline. You can say pipeline of
Mm.
function because they have whatever you pass internally, they become a stream of element. Stream of element. These so output would be this. You can say again a stream of again the same element. Then again pass this different function and return the stream of your stream of another element. And whenever come the final function, a terminal function, they return actual value. Maybe void, maybe non-void, maybe return any specific value. So internally,
Yes.
these are the intermediate. Why? Because they are returning output as again one stream. Means again set of a pipeline or sequence of function continue to execute, right?
Yes.
So these are the some basic terminology. We are going to take a couple of examples so that we you can correlate everything. But objective is that there are a couple of things. Please be keep in mind whenever you are creating any stream, any stream. Let's you create the stream one that contain the three function pipeline function. And here you can associate source of data. Source of data may be collection, maybe array, anything. And output you can also associate. Output can be collection, can be string, can be any value. So these operation, these functions is only start executing if you are associating at least one terminal function. If you are defining any stream and you are associating multiple function, but these function if are intermediate, you are not defining your terminal
Terminal.
function. In that case, our stream is not going to start. A stream is only going to reading value from source to start processing function 1, function 2, function 3 until they not found the terminal operation. So
Okay.
first, what do you think? They are not run sequentially. Code is not going to first call this function, then this function, and say, hey, this is terminal, no terminal operation, then revert back. No. Somehow the intelligence built in the pipeline, first they are going to scan your complete pipeline and check all the functions. And last, if any terminal function you are associated, that say, hey, let's go start pulling the data from the source. Okay, and let's do perform the operation one by one. So this feature known as a lazy evaluation. So
Lazy
one of the key
evaluation.
feature of Stream API is the lazy evaluation. Many other programming languages support this Stream API, but they are not offer this lazy evaluation concept. Means always in the other programming language we can talk, they are start executing first function, second function, third function, whatever function associated. Even you are associated some terminal function or not. Terminal function means they are returning actual output, right? If our Java compiler think if you are not associated any terminal operation, that means you don't want to some output. If you don't want any output, why I can start executing this function? And later part I find, oh, you don't want to collect any data. So why start streaming, right? So due to that, This is the very effective and sometimes you can say performance gain we find in a stream API due to this lazy evaluation.
Okay.
Is it clear?
So
The lazy,
yes, yes. I also face a doubt in like chaining system, like how filter is working, how map is working. If
yeah, we're going to.
yes, it's like what is the return type of a filter? Is that working based upon that, or like how it is working? If I'm using the chaining method, then if I'm using the count, why we are using that count at that moment only after a map or
Right.
something like any match or some anything.
Yeah, we're going to talk.
Chaining. Yes, please. Okay.
So here, any functions or you can say terminal means from here you want to get actual output. Okay, that is the meaning of terminal. Lots of terminal function like you take like a sum, count, max, mean, collect. All are the terminal functions. We are going to take example. And
Yes,
like
yes,
here you can say a filter, map. Uh, these are your intermediate operation. That means they are take input and again return as a stream of the data. Take input again return as a stream of data. Our stream is chain again continue the next chain. Again continue the next chain. So this is happen between the intermediate operation. But whenever we reach the terminal operation, after that, not return the stream of data, but actually return the out. Due to that, say this is the terminal operation, right?
yes,
So all these theoretical concepts is okay, and let's go some kind of a talk API. How we can write this code, how we can achieve this functionality, right?
yes.
So in short, you can say if you look be carefully, stream API look like iterations of your. Let's give we have a list, a collection of data. You are just reading one by one automatically, right? And do some operations and letting out. So
Yes,
something
yes.
just look like before this stream API, all these operations we can do manually using the for loop for each. Okay, we are okay. So let's example. So okay, so here let I am just take some 10 number. Okay, so you can say maybe uh, arrays. This and we can just return maybe 10 number. Okay. So here we are going to create the 10 or maybe 5 number, 10 number, any number. So this is our
Yeah. So what is the shortcut to have this return type value in IntelliJ?
okay. So let's sorry. Just I remove
Yes.
just in the last you type the dot,
Dot.
okay, and type the
Okay.
var
Type
variable
where. Okay.
and
Dot
just
where.
select, okay, and they
Okay.
give you, okay.
Thanks.
So here you can say for the pipeline or stream API source and the output is the again destination. Source and destination is not always mandatory. This is the collection or collection, right? Here might
Yes.
be collection, here might be no collection. Might be here no collection, here might be collection. So here our pipeline is not any tightly bound. What is my source of data and what is my destination of data? Data nature can be anything.
So
Okay.
here, sir, I have a question.
Yes.
If arrays dot as list is immutable, then can we modify the data in streams?
So notice here what you say. I can read value, okay, and I can transform the value in another form. I can
Yes,
transform
yes.
the value in another form and give to another value. Yes.
In the case of immutability, like I know that as list is not a immutable method.
So
uh,
uh, let's understand the meaning of mutability. Okay. So
okay,
here, let's this is the one object. Okay.
focus on
Object.
immutable.
Yes. Let's
Okay.
understand what the meaning of mutable and why say immutable. But till now not talk
Yes.
the mutable and immutable. So let's understand the concept. Let's
Yes.
we create one employee object. Okay. So this employee object might have a name and might have a age. Okay. So once you created maybe employee ID, right? These are three fields you can create it one employee class, right? Employee object. So here employee ID is the data which I want for each and every employee should be always the same. Like if I'm joining any company, my employee ID cannot change. Maybe my name can change. Maybe my address can change, right? So
Hmm.
particular uh, attributes cannot change once created, right? So if
Yes.
one time any variable, if you create variable x and assign value same. Okay, so if this 7 value, all the programs are still preserve 7, that means this is the immutable kind of object. But mutable means this value, if I'm allowing, developer can later part maybe change 7 to they can change 8. That means
Hmm.
this is the mutable object. Okay. So here, if you talk about any list or a collection, so pipeline just reading data from here. They are not going to update and modify anything in this original list. So please note, Stream API is just reading your data from this object, okay? And
Okay.
after doing processing, they return the new object to you, new data to you. They are
Okay.
not going to do any kind of modification on your original list. Right? So this is the
Okay.
thumb rule. Stream is never going to modify any content on the stream, right? So if
Okay.
your source of data mutable or immutable, doesn't any make sense because stream is
Yes.
just reading one element, and they're not going to again modify here. No. So due to that, stream say, this is my source of data. I am not anything going modify on your source of data. Source of data would be always same copy. What I did, I read one element. Let's from here, I read one element. I have a number. I do some modification here, and I am going to store maybe in the different kind of collection. Okay, so this collection
Yes.
is the mutable. They read another one element, do some processing, they put in another collection, right? So
Yes.
source of your data in the stream pipeline is, you can say, effectively immutable, means logically, theoretically, stream API guidelines say, while after processing, don't go modify the original list. This is the general guideline. But programmer have a lots of flexibility. They can sometime might be you find the code where after doing processes, someone can going to modify the same list as well as. Okay.
Hmm.
Instead of
Yes.
returning the new one, they are going to the modify. Sometime we can violate the rule. But logically, as a design of the stream API, say don't touch your source of data. Source of data just for reading only. For reading any object, maybe mutable object or immutable object, there is a no problem, right?
Yes.
Okay,
Yes.
so
Yes.
it's clear. And okay, good. So here source say, for example, we given a collection, but this is not the only thing. Couple of example later we're going to talk where we are not going to take source as a list, maybe source as a anything. So
Mhm.
okay,
Yes.
source
Yes.
source can be file, source can be number, source can be stream API already provides some kind of generator class. Okay, you can generate the stream from the some specific, maybe the int stream API or a stream or long string, float string. All these have some specific API. They can generate the stream. They can generate a stream. that considered as a source of string, right?
Yes, yes.
We'll talk later part. Let's. So here we have a. So in this lines, why say it is a collection? Because they required one container memory where these all value are going to store. Here they are going to all value are stored, right? They required memory, at least this is the 5 element, right? So due to that, this is the collection. Collections are the storage location. But now I am going to using the strings. Let's say I want to double all the value and sum it, right? I want to double every element, and I want to sum them, might be, right? So before doing this stream API, we can achieve without a stream API, because stream API is the one way, but not the only way to serve my purpose. Okay, so let's think, if we are not going to stream API, how stream API do, and without stream API how can do, and then we can correlate same thing whatever you do manually, and then why we do the same repetition of work which library easily support us, right? So what you do here? So let us. I am going to just say for loop. This is the list. Say hey, they have a one number, first number, okay, and this is the list. You know how to retrieve, right? So here
Yes.
what this for loop are just going to read one element from source. So if I say hey, yes, so if I'm run here this code, I'm able to read one element from this collection. Okay, it will compile it. So here notice each and every element we can read from my source data. This okay, fine. So
Yes.
first things, these activities is now stream do automatic for you. You don't need to write for loop and your list or size less than greater than everything. Don't need to just say, hey, stream is doing this is for internal to you. So sometimes say stream do uh, uh, iteration internally. Not say, hey developer, you are go and say read how to read in the data. So second thing, what my objective? We are going to transform each number to the double. Okay, and after that, so how to do double? Now we have every number. So how to double? You can say double. Maybe
And end
you
to
can
end.
just say maybe make it, let's say simple, and make double equal to simple, say number plus number, okay, whatever. Okay, here you are doing double it. Yes, what are we doing? Whatever the number, we are just adding two times and return the double. So if I'm passing it, what's the double? So let's say double. Let's check. It's a double. Instead of two times, let's say comma double equal to plus double. If you run. So here you are doing
Yeah.
reading one by one element, and after that you are going to double it. So here notice this is the input number one. Second operation you can double it. Second input and double it. Third input and double it. Fourth input and double it. Fifth input and double, because your collection is over. Right? Let's then you say, hey, I want to sum it. So what you can say? You are going to the sum every number, right? So let's, this is the things till now we have covered. So the same thing, how we can achieve from stream API. Let's say, okay. So stream API say these things you can do easily. There is no problem. Okay. And you will say, hey, maybe this double it can be my function. So here say, hey, might be, I can say, this is a small logic. Maybe here you can calculate interest, and any function can be. This line can be anything. For example, here just adding the two number. But might be this can be a particular function. Maybe so, hey, let us instead of this, so the main method, let's say write one function, hey, static return double it, okay? Double it. This will take one input number and just return whatever your code, right? So here say just return. Okay, return. So what I'm saying is now here this operation I am written on a function, right? And I can say, hey, this is my function. So I am going to call, hey, already have a double it function. I can pass my number and I can return the, okay. So what I'm doing here, I'm saying, hey, whatever the number, I am going to call another function. Hey, this is my function. This function do something operation, something, and after that maybe returns the some uh, some output, and these outputs we are printing, right? So still we are doing, hey, this is the one by one loop. I am calling one function and printing them. Okay,
Yes,
till
makes
now any
sense.
confusion? Makes
No,
sense.
sir.
Because why I am writing this line? Why the someone question say why you are writing method already? You can do the same thing like here, right? Here, right? Can do. So why say if this line might be simple, so someone can easily understand like maybe double it or twice of number. Why not I'm giving logical name? Hey, here I'm going to double it. So this line makes okay, whatever the input you are going to double it, right? So here now as a programmer, our responsibility, whatever a business logic, I am give the logical name so that someone can read this code, be carefully understand. So method is the convenient way to give your idea to the developer what the code is doing. So here this code you are given the logical name. Hey, this is my logical name. For this code, I am giving this name as a double it. So anyone can read carefully this my method. Okay. So he said, hey, double it. That's good. And
Yes.
after that, you are printing. Good. Okay. Good. So after that, next, I want to maybe sum it. So you can say, hey, you can simply say sum variable. Let's here say, hey, integer sum. So let's be simple. Don't go complex. This is one function. Okay, letter pattern. Okay. So till now we are very good. How in the collections we are going to do some operation one by one reading, doing one operations, and what the returning value. Till now we're not returning any value. Might be you can say. So what is the outcome of this function? Somehow here I'm right just written a print, so you cannot visualize what this function for each do. They are just printing. Okay, so maybe printing, or you can say why not return some value, maybe a string or maybe some summit, anything depend upon use case. Okay, so let's as of now let's jump how the same code I am going to use the string API, right? So first thing, understand this is the my code which I am written. What they are showing, this is our collections of data. This is my collection data of data. One by one data reading here, and after that, just nothing they are displaying, printing. So this is the one function. Maybe you can say, hey, similarly, I can give this logical name. Hey, this is my static function. They are not returning anything, and just say display, right? Yeah, print. Okay, print. Okay.
Yes. Yes.
So let's say, hey, I say print it and take one input now. Okay. So here you can say just print it. Okay. Whatever the digit you have. So now it's code simply, hey, we have a for loop and we can double it and we can print it. So same thing you can do very concise way is using the your simple Java for loop, right? Similarly,
Yes.
you can say now the problem is I can avoid these things as well as possible. Why manually I am going to iterate somehow? This is known as a two kind of iteration or two kind of loop. One is the internal, one is the external, right? So here we as a programmer saying compiler, hey, using the for loop, you can iterate this thing. or while loop or do while loop, somehow I am giving the hint to the compiler to do. So we can avoid this as well as somehow. I don't want to manually say hey, for loop and double it and print it, right? So here say stream API now come. Let's stream API see. These things are candidate. Now this is the two function. One function take one input and return one out. This is a function take input and return out. Notice this is the function. We pass one input and return another output, right? This is the example of your function. And similarly here, this function take input and not return anything. So this is also function. Okay. So here we have a two function. We can make sequence of two function or make a pipeline of two function. Surely. So whenever in your application we have a couple of function and you want to execute sequentially, yeah, one after another. At that place, you can think here stream help us, right?
Okay.
So in our scenario, we have a couple of functions. I want to perform in a particular sequence, right? So here is a good candidate. We can go and leverage the stream API benefit.
But sir, like if I'm using method and
Yeah,
I'm calling that by using some static method, that thing is called factory method, right?
yeah, you can give some terminology name factoring method. Yes, very
Like double
important.
it, these are called as static factory method. Just
Yes, you
confirming.
can say. Yeah, you can say it is a factory method. The factory method generally uh, used in the terms when factory means they generate something, right? uh, like a factory of shoes, factory of something. So whenever generally factory method say where you can generate some object, yes, some number, yes, you can say factory method, yes. But different design patterns where maybe we talk factory method, something different. Not that this is simple. I'm trying to. It's simple function. Take input and return output. Might be I'm why writing static because this methods currently I'm using in a main method. Might be I'm written some separate method here. At that time, might be I'm not writing a static, right? So here our purpose
Okay.
in a stream API, I'm talking always function and sometime you also know the method, right? Factory method. You say factory method, right? I'm saying this is a function. So what are the differences between a method and function? You know anything? When I can say it is a function, when I can say it is a method. What do you think? What are the logics?
Earlier I was aware, now I forget like what is the logic.
Yeah,
Uh,
let's explore. I'll
okay.
talk with it. Okay, not in this. I'll talk. So you think. So whenever functions are method, let's see why in this question why need a function? Function means we are going to perform some kind of coding, line 1, line 2, line 3, and want to give some logical name, right? So that anyone can understand. Let's like sum it, like here a double it, right? So double it by a function because inside I am going to take one number and plus one and again return it. Three line of statements and might be I can use multiple many places. So why not just club and give the some logical name and anyone can use in any places, right? And one key benefit, these functions are not associated bound to any kind of object. Okay, they are independent to the object. So whenever any function you are going to associate with any object, that's become a method. If any function are not associated with any object, that is the function you can see. So notice here, these functions are not bound to any object. These are the independent to any object. So whenever you talk method means they must associate to the particular object. Means you have to create some object, and on the top of that you can call particular function. Let's function. So this function
Yes.
become a method because they are referred to the particular object. Maybe they can access any internal variable, internal object, right? To maybe
Yes. Yes.
modify something. So any function you can say methods if they are associated with a particular object. And this function can access the internal variable state of an object, and they can read, they can modify. Due to that, say, hey, not a function, they are doing a specific thing for a specific object. You can say this is the method. The method is always associated with a particular object. Function is independent. This function can be applied without any method or without any object. Still, you can use them, right?
Yes.
Okay. So let's stop. We are going to the different direction of this. Okay. But not this. This is very interesting things to discuss. So
Yes.
here say
Yes.
why this code is become a candidate for my stream API, because I can build a pipeline of these two functions. Okay. So whenever you are writing some business logics and your business logics have a couple of functions and you want to exclude maybe sequentially or conditionally, that time you can think here is the good candidate where I can use my stream API, right? So let's look. So stream API, how to is used. Generally, in the case of collection, uh, stream API by default uh, given by this list interface or any collection interface. So if you are this list, you can directly say, hey, this is my source of data and a start stream. Okay. So whenever you write this way, this is become a source of data, and now you can start one pipeline. Look like this is the for loop. This is the for loop. Look like just not, but look like a loop. This is the for loop. For loop say list, here you pass, and here's a loop. That means here you are saying this is a for loop, and you can pass in the list as a content. So for loop no hook, I am going to read one by one element and passing here. So all these things automatically just say, hey, this is my stream. Stream is now this is a source of data. This is a source of data. Now I am going to read element whenever you can associate some function. If here I write in a variable, so notice they return the stream of integer. A stream is a stream of integer. Okay, and let's if I say, hey, so till now clear, stream is the interface, and that interface means just set a function. You know what is the interface?
Yes. Yes. It's like a constructor. Not constructor.
Not a constructor. What is the
It's
interface?
it's kind of a rule like interface where we have some abstract methods
Yes,
inside of it,
you're right.
and we can achieve 100% extra abstraction using this, and we have default and static keywords if I needed to create some kind of a methods.
Right, right. So
Yes.
interface means just like some predefined contract. Hey, this
Contract. Yes,
any
contract.
object, what they can do, right? So you can create one object. So what they can do? They can speak, they can talk, or they can run. Okay, maybe we have three behavior this object can be, right? Similarly, if the list is an interface, but what this list can do, the basic behavior, basic functionality defined in the list. But those behavior or function or you can say methods depend upon the nature of object. Might be this list for the array list, maybe for linked list, maybe for a linked hash set, right? So implementation can be different, right? Okay. So interface is just a contract. Hey, this is the one function one and function two. Anyone can go give the definition of this function and function two, right? So the implementation classes are going to provide the definitions of this method, right? This function. So here's a
Yes.
stream. Yeah, stream is the interface one. So they have defined some, you can say, common functions. Let's open a stream. Okay. So notice the stream is interface. In this interface, generally we can define some function like filter is a function, like is a map is a function. Lots of function here defined, right? But this who can provide the methods? What is the logic of this filter? Okay. Stream is an interface, they have function filter. So what is the business logic? Who are going to write? Or maybe map function. This is the map function. So this is the map is a function. My question, what is the business logic? This map return what? What the code? Who going to write the implementation? Okay. So whenever you are going to use interface, right? So interface have defined some kind of a function, but those function actually what they perform, they are not telling you. Somehow, like here list, this is the implementation class which give you the detail, right? Similarly, here say list dot stream. That means this stream method internally provide all the implementation of this interface method. So now look like a become a, this is your interface and this is the your implementation object. Okay, from this object you can call the filter method and map method. And what is the business logic of filter and map? This class must be provided. Whatever the object you can say, any object. So whenever you can say stream have some function one, function two, like here filter and map. So filter map, what the business logic, what the code they're going to the perform, that is not written by this stream API. Stream API say, hey, this is my API, this is my interface, and these are my function. But how this function behave, you can take decision.
Okay, could
Okay,
you go inside of this dot stream method?
this one. Yeah.
Yes, yes. So return, could you go inside of this stream? So yeah, this. So I just wanted, yeah, there is a return new reference pipeline dot head. So
Notice
actually,
somehow they provide the implementation classes for your
yes, yes.
interface.
So could you explain this thing, like how it really got worked and how the return type,
Yeah,
mean like how this, yes, yes. Hope you able to understand like what I'm saying, like how
yeah,
the it is creating an object using list dot stream. Yeah, this method.
yeah, yeah. So this is don't go complex, just under the simplicity. Okay.
Okay.
Here stream is very as simple as simple. If you want to make as complex, you can make as complex. Okay. So let's look anything as very simple. If let's
Okay.
simple, if we have a one interface, let's one interface, maybe I my interface, okay, my interface. I have only one function f, for example, right? Good example, let's write that. Okay, so let us here interface, my interface, okay, interface, okay, and I have just one method, okay. Let's why say method? Because this method is going to provide somehow some implementation class, right? So this is the my method. They just take maybe some integer x, that's some return integer x, and return some kind of integer again. So if this is my interface, and I can, so question might be here, this is my interface, similarly this is my interface, okay, and here my maybe my interface object. What here I can write? Here must be I can write a method, then provide the implementation, right? So here I cannot write in the case of like, hey, interface anything like here maybe a new kind of things, because this is the not possible with the interface, right? And here you can say, hey, let's go to write my call method, right? Pass some code, right? So as of now, it is not possible because this is the method. What this I pass 4 input. What is the logic of this 4? What this method do? Because here I can just give in the contract. This is the signature, but who is provide the implementation of this method? This is
Yes,
so
correct.
that here we cannot write interface. So somehow notice this method means this is the function logic. Somehow we write in a particular place, right? So what is the place where you going to go, someone going to write this? So due to this, hey, let's write one of my implementation class. Okay, I am implementation. Okay, my interface implementation. Okay, this is the one my and implements. Okay, my interface, right? So now this is the one class who's going to implement this method, right? So you can say, hey, This is the method I am going to give in the business logic. What this can do, right? So this can be just whatever the x number multiply by x multiply by maybe 3, right? And just return your x or something, whatever the business logic, right? So notice
Yes,
this is
yes,
the interface, and this method somehow someone going to define. Someone means this is the class they can define, right? So here say now this class I'm going to, hey, here I can use my, here this class. Now it works because now this methods is no, the logics of this methods are implemented by this side of object. Okay, this is known as
yes.
a runtime polymorphism. So
Runtime
now
polymer.
if I run, that means our number, whatever I pass, multiply by 3, I'm getting something, right? So this is the one way, right? This is the one way. Generally, we are doing this. Any interface, you can call. So similarly, like this interface, similarly this the interface, same interface, this same interface, this. If here say, like say stream dot, let's stream dot map. Let's I'm saying, okay. So that means someone giving the definition of map. What map do, right? So here I know ki add method. What add method do? Add method say, hey, take some number, do something and return value. So we are very clear right here.
Yes, yes.
So let's visualize. This is the one way. That means, is it really always required to write this class? Question maybe optional, maybe not required. So how alternatives? Let's. I don't want to here new any class. Maybe I don't want to create the new class. This is the one way you can achieve. But what happened? Let's I comment out. Okay. And I'm saying, hey, I'm not going to use any existing inputs. Maybe I want to, okay, maybe another object, okay, and I want to provide the different implementation. So second approach here might be, uh, anonymous function. What is the anonymous classes?
Yes, yes.
Okay, so anonymous classes say you can create the object. So here, understand, this is the my interface. This is my interface, right? And this is my implementation. Okay, let's say this is my interface and this is my implementation class. So whatever the here function definition is given, I can going to override or provide the same function, but actually the body. What is the body, right here? Here.
Yes, yes. Inside of
And
the
this is the my
int
interface. This is the my interface object reference of this interface. Okay, and I say, hey, interface my object dot call your function, right here call. So they are going to the calling your actual business logic here, because there is no any business logic in the interface, right? So they are going to redirect your code here. So somehow this code you require, right? So somewhere you require this code, this business logic. Okay, and this business logic you can generally written in the particular method, a method inside a particular class, right? In this way, this is the implementation class and this is the method. So here first you're going to create the object of this object. Here you can create the new my object and then allow interface can call this behavior. So the,
yes.
the intention is this important here is your business code, right? So is it possible we can avoid this class unnecessary call class creation? Yes, we can avoid because our here objective call function to there is no more interested. You are really going to write this class, are really going to this function. I am only interested this part, right? I am only interested this part, right? This is an important implementation. So this code directly you can write this complete code. This complete code say anonymous class. A class is the name that means simple class. If you writing this line of code, this line of code, that means a simple class. Okay. But if I avoid this, just remove it, then this remaining part, what becomes? This is the anonymous class. A class then don't have a name. So question, if a
Yes.
class don't have a name, how I can use them, right? How I can use them if they're not writing the name. If I'm not writing the name here, so how, what I can write here? What I can write here? Okay. So here anonymous function say, hey, this is the complete business logic. This is my complete business logic. You can directly write here. Why need a new? So here you can directly write whatever the code you have. Whatever the code you have, you can say new. Okay. And here you can say, I'm going to whatever this is my code. This is my code. This is my code. Okay. This is my code. This is my important code, right? This part. This is just you paste here. Just okay. And
Yes,
so
yes.
somehow compiler is very confused. So here new means you need some kind of object. So you can say let's this is do this. Okay, just say, hey, this is the object I'm going to create, and this is the my name. I just close. Notice here semicolon, new, and this is your class, and this is your close and semicolon. So here, this place I'm going to use the same interface name like this, right? And whatever the code here written, whatever this code, complete code I'm using for this new implement, right here. So here I can give the different multiple different business logic, right? And
Yes, yes.
now this F1.4 means they have a different implementation approach. So this is known as you can provide this method implementation via anonymous class. This is your named class. This is your anonymous class implementation. This method is provide the anonymous class definition, which they are going to call and they give this business logic multiple of 4, right?
Yes,
They the
yes.
this is the one implementation. If you pass 4, they return the multiple of 3. You call same the method again, but the different implementation, right? But this is the class way. This is your interface, right? If you run, they are
Yes.
calling this for this and calling this for other. Right? We just you know. So why I'm going to talk here, because in the interface, whenever I'm going to talk map, okay, somehow what's the I'm missing something. Okay. So some while talking, you have to write this again, right? No?
Yeah, yeah, it's fine.
Something I can just
Yeah, for now it's fine. For now it's fine.
it's not just here. So let's run. So run. But this is the basic concept. Once you clear, you can easily understand to map what we are passing, what the definition meant, right? So notice if you pass somehow, that's somehow as of now I can just start this comment, right? And notice here I am just print something here. That's a good option. Here you can yes, what they return value, right? Let's say right there. Uh, Good option. I can take that's out here, right? Okay. Because they return value, right? They can
Yes.
print the value. Okay. Here you can print the value. So this is the uh, via new implementation class, right? And same thing you can write here. But here you pass the uh, interface itself, or you can say anonymous. Okay. Yes, and here you can use this here value, right? So this is the class. So let's run. So it's run. Okay, here you can pass the number n, 3 multiple of 3, a multiple of 4, right? Different implementation. And
Yes, yes.
now here we are going to something tweaks. Notice here IntelliJ highlight something. This something gray out. Notice here. So here compiler say
Yes, yes.
you are writing something extra. Already left side my interface. Same you are writing right side. I will. Something unnecessary code you are writing that's maybe not needed. You are mainly more focused on your this part, right? What is your input and what is your output, right? This part. Okay. These things, whatever interface name, what is the method name, already defined inside my interface, right? So unnecessary, you are duplicating, writing this public int method name and again new and interface, right? So for business logic, only important what is my input and what is my business logic, right?
Yes.
So can we avoid this code? Maybe just copy paste. So instead of one, I am going to another implementation. Two, okay, two. Here say, hey, I am only interested from here, not I want to interested all the ways. I want only interested this part. Okay, unnecessary things because this interface, if you look this interface, already have a interface name and signature. So why I am going to write? I know surely I am going to implement this line, right? So here say, so compiler somehow not happy. What are you doing here? So how I can know okay, this is my input and this is my function name. And here is the concept come here, lambda expression. Okay. So lambda expression say, hey, I can write this code using just one arrow symbol, right? So you can say whatever the demarcation between that, you can just write arrow. So
So,
this is
so
yes.
Lambda can be applied it only on functional interfaces, or can be
Yes,
applied
as
it?
of now, I'll talk yes, why yes. As of now, you are right. Okay.
Okay.
So here we are saying this is the not okay. So notice somehow because this is one open, this is one curly bracket, right? So here my this is my interface one, this is my interface two, and here say hey, this is my interface two. Now this is become a some lambda expression. I'll talk six lambda. So this concept known as a lambda expression. Okay. So what here doing? Just whatever the here map method you want to give the definition. So this map method you are given definition. Hey, this is my interface, and this interface have a one function that is a one function method take input x take input x and return some value. So whatever the actual business logic here say hey this is the my input parameter and this is my your code of the body, right? So this is
Yes.
now you are right. So something maybe now want to multiply your multiple of 4, 5, right? You can change the business of this multiple of 5 return, right? Whatever the number of. So till now, if you notice, one methods, this method can be implemented maybe from the implementation class, maybe from your anonymous class, or maybe from the lambda expression, right?
Expression.
Next question, why I am going to writing this code is a lambda. It is clear, there is no problem. But here lambda have a lots of more benefits or conciseness. Something lambda already know. You know this is the interface, and interface already you define. Hey, this interface is the method input type integer. So why again you are passing here data type integer? I know already. Don't pass. Something with the help of lambda expression, you can unnecessarily avoid. Let's go for the third implementers, right?
So in this, can we create one more method inside of this interface?
Yeah, as of now, no. Okay, this is the whatever the lambda I'm going to talk about the only one method. Why I'm going to talk? Because
Oh,
let's see. Why? Because notice here I can write only one input and only one output, right? If my
Yes.
interface contain more than one method, then where I can give it what is the input, right? The only problem, you can say design of the interface, I can give the implementation of this method in any places where I want, right? So if this is the not single method of, there is a, if we write a method two somehow, let's as of now, let's control it. I just say as of now we can implement it. If run, it's work fine. So let's introduce. You say, hey, I can write the new methods in this interface or not, right? And what are the challenges? Why we cannot write, right? It's working, right? So let's I am go to this interface and say, hey, another method. Let's see another method, method one. Okay, right? So now here I am going to give the definition of method one or method two. Because this interface, you can call two method, right? Method one and method, right? Because they have interface two method, right? So here I can call method or method one. So here I have a only one option. I can give the definition of only one method at a time. I cannot give the two here, right? So due to that, lambda expression say I can provide your implementation method for a specific method, only one method. I cannot give the multiple because we have maybe have different syntax may be required, comma and maybe method two. So it's get confused because notice
Yes.
here I can let's allow compiler allow, okay, you can say this maybe comma somehow some another, right? Maybe this is the method definition, this is the method one definition, right?
Yes, yes, got it.
Somehow they are not confused somehow ki this is the also same parameter, this is the also same parameter. What are you talking? Okay. So due to that, Java designers given us some kind of restriction, or even you can say every programming language where they are supporting the lambda expression is just for the only one method. One method means now here it's clear this is the method one. What is the business logic you are going to write here, right? So this is my input. This is my input. What the output? This is my output, right? So this is the only reason
Yes.
while the lambda expression, the interface which you are going to refer, they have just only one method. Even notice while the implementation, I am not writing even a method name here. This is method name is also for unnecessary, right? So here,
Yes.
lambda expression did some kind of uh, another way. Okay, so even question is that if this is the interface, we can write this. That's good. And let's one more refinement. So lots of refinement we do, but I'm trying to explain this. Any interface you call the method. This method somehow, somewhere, someone provide the business logic. Maybe inside your class, maybe inside a class, or maybe inside your lambda anonymous function here, or maybe inside your lambda express, or maybe inside your method reference. So let's same code, this code, maybe this code I can write, let's say here, maybe a static uh, here. Okay, and same thing, whatever the business logic here, something I am written multiply by let's 6. Okay, so in any methods, in anywhere, your same signature, input same and output same. Math. So this is also candidate. So here I can say, hey, no, I'm not writing this. So here you can say I'm going to reflect. So till now, any doubt with this approach?
No. Yeah, everything is fine. Able to understand things quickly.
Slowly, initially, couple of time will take to start one basic system, because I want to explain basic why I'm going to pass something here. What is the map function? Then who will provide the implementation, right? With a simple example, right here.
Yes.
So if these are the basic clear, we'll move slower. So even uh, so- okay. So let's I write one more function. Even I notice here I'm calling always these things, right? Interface. So instead of that, I can write one method like a static, maybe void or tick, and take input as my interface, right? My interface. Why I'm going to explain interface, okay? Interface. And here I can simply say whatever my interface, okay? Whatever my interface, I'm calling this function. And right? Question is that now I can just say and in this place, in this place, in this place, all three places, now I can call my this function, take on, right? Or just print, okay? Okay.
Yes.
So here I can say, hey, take print, and I can call my implementation one, right? Okay. Okay. And similarly, I can call here for the implementation, right? And even I can call here for implementation. Where is this
Yes.
first implementation? This is the second implementation. Where is so all three, right? This is the interface. Interface. This is I message also, right? For only interface. Okay. That means I have written one method that will take one interface, right? And in this interface, call the method. So if you read this code, somehow this is the interface name and this is the method name, okay? And call it. So whoever going to call this method, always they provide someone the implementation class. Like here, first time you pass the implementation class via class implementation. Second time I call this method implementation via anonymous. Similarly, third time we call this method from this your lambda expression, right? So this take, if any method take interface as an object, okay, then this take method you can call from different implementation. Maybe from the your implementation class, maybe from your anonymous class, maybe from your lambda expression, or maybe class from your even good option. Even you can directly copy paste this complete code, right? It will
Yes.
also works. Why? Because if this code, this line of code, I can assign one variable, right? And I passing variable, right? So instead of this variable, I can also pass this complete code, right? So this code or this variable, both are equal. Notice this equal to this means this is the left side, this is right side. So if our method can take left variable, then also can take right value. Yes. So here you can say completely you can pass the implementation. So many
Yes.
places you can say take and pass some code. This code means what the code means. This code means this is the implementation class. What this interface? This is the take interface. Take interface is the method public this. This method implementation class code you are going to pass in the take method itself.
Yes, can be say like reference as a parameter.
Yes. And even any method will take one input and they return out. Even this take not only this code, and even you can uh, concise here, even this is not required, unnecessary thing. You can remove it, it's still working, right? Even unnecessary two, you can even remove this. Okay, this is also
Yes.
working. Even this
Yes.
is the
Yes.
return statement, and maybe you have to write this code, maybe just minimize like this, right? You can write this, right?
Yes. Sir, yes.
Even you want to unnecessary one liner, even I have to return remove this. Even we have to remove this, even we have to remove this. So your code look like this,
Single line code.
single line. So what this mean? So step by step we are reducing. First, this is one. Second time, what reduce? You reduce this variable, right? Second, you reduce with unnecessary things, right? Unnecessary, okay, hey, unnecessary things I can avoid, right? And even this is the two-liner code. I can next time say, hey, two-liner I can optimize in one-liner as well, because this is my return. So directly I can write here, and it's not right.
Yes.
And if anything one-liner, even we can avoid more things. Hey, don't remove with return, and there is no need to open and curly braces. Okay, this is the next
Yes. Yes.
this here, this here. Okay. So look like someone if written code this. So what the meaning? That means this is the meaning means this is the code. This is your input. This is your business logic and return back. So whatever written inside your method code, that means this is the things. Just only the representational change.
Yes. Yes.
So here, notice here. Initially, here your implementation class provide the multiple by 3. Anonymous class provide the multiple of 4. Lambda expression provide the multiplication of 5. Even why need these things? Even we can directly say multiplication of 7, a multiplication of 8, right? Multiplication of 8. So I can call this take function that take interface have whatever the method. This implementation class I can pass different. So whenever somewhere you look this code, we assume that you are going to provide the implementation method detail. That means this is my interface. Interface. What is the method? What is the business logic of this method? Who will going to the provide? As a developer, which are going to call this tech method. I'm going to call. This is
Yes.
my responsibility. I'm going to provide the definition of this. Right? So now I'm not going to write the interface or implementation class, anonymous class, or something. Even I'm saying, hey, this is my input and this is my business logic. Whatever. Here you can write the bigger business like this way or this way. Everything is acceptable, right? So till now it's clear. Any method that take input as an interface, and that interface have a only single method. So this method implementation and business logic, whatever you want to do, this code, this is the code you can pass while calling those methods,
Yes. Yes.
right? Good.
Yes. Yes.
So now this is the basic, because in Stream API, many things we are going to write in this way. So be clear whenever I'm
Yes.
say map or filter, I pass something here. So we assume. Now let's come on our actual stream, right? Here say I have a stream, right? Here say stream.map. Okay. And notice, let's check the map this is the interface, this is the map. Okay. So if you do map, map take another interface. Notice this is the what is this
Function.
mapper? Mapper is the interface.
Yes,
Interface have a
yes,
method like this. So somehow
yes,
I am going to the provide implementation that take one input and return one out.
yes, yes.
So what the my input and what the my output? So similarly
Input
here,
can input can be
here,
anything.
here also step by step you can understand. Maybe you can implement from the implementation class because you know this method taking the interface, right? So
Yes,
here we have these four options you have. You can provide the this is the implementation class or anonymous or lambda or even method references. Here I'm just one speak. Speak. Here even you can call take any method. Please follow this syntax. Notice this is the method. Take input and take return out. This is the same logic here. Take input and take return out. So
yes, yes,
this name is also not more severe. Here simply say, hey, this is my double it function. Simple. It will also accept. You can say, I am passing the code already. I am written here, right? That take one input and return out, right? So even you can write this code or this code. Both are the same. Why? Because this is the implementation of your interface
S-
method, right? This implementation of your this interface method, right?
yes,
And
yes,
notice already I have a one method, similar syntax, same input and one output. So this is also the implementation of my interface. Name can be anything. So in the case of interface, might someone notice this take is the take interface. Interface have a method like this, but here you say take it double it method, different method. But why possible? Because double it method also follows same syntax. This is the important part, your input and your business logic, right? This is the
yes,
important, right? This is the same as our interface implementation. Maybe here name method or anything, don't worry. But in input and the business logic are the match. Due to that, any places where you can pass lambda expression, where you can pass method reference, or you can completely pass your complete code, or even you can pass lambda expression, or even you can pass the anonymous class object, or even you can pass each and everything are the same but different view.
yes,
So here in this case, map, I can pass complete this class. Maybe I can write my one class. Maybe like this is the notice. This is my functional interface, right? So I can write here. Hey, this is my functional interface. Functional interface. I am for integer. This is my integer, and this is just import them and say IMPL. Okay, FN IMPL. Okay, equal to, and maybe I can implement maybe class. Maybe simply you can go here, write another class. You can do right. Similarly here, you can write your simple class. Hey, class my function, right? My function of implements functional interface. Yes, a functional interface of okay. This is the things right here, and here you can override what this function say. Apply method. You can override apply method, right? Here you can say override your apply method, right? So here look like this is the interface you are implementing. Similarly, here you can also implement, and here say whatever the object I am written. So by default, this are the object because you have not defined, but we are notice I am basically working on the integer. So I can just instead of object, I can say let's play with the only integer, right? Here integer, and you can override the your integer method, right? Override your apply method. This is the somehow mentioned here. So, okay, we are the So let's continue later. We are the too late, right? I'm forget, right?
Yes, yeah, it's very late.
Please ping me whenever I am teaching. I'm forget from it. Okay, let's continue after this class tomorrow. Okay. Sorry.
Yeah, yes, sure, sure,
We'll
sure.
continue later part. Just
Okay, sir.
invite me. I'm somehow I forget. Okay. Sorry. So we'll
Huh.
continue on after here tomorrow. Okay.
Okay, sir. Okay, thank you.
Okay. Thank you. Good night.
Good night.